Good morning, students. Today we are going to discuss electrostatics with SHM connectivity concept. It is useful for IIT-JEE, NEET. Let us consider two identical positive point charges are fixed apart to L. Q are separated by a distance to L. These two is fixed. Capital Q is fixed. And separation between them is 2L. Now, a third charge plus Q is kept at midpoint and displaced slightly along the line joining them. What happens? Is it execute SHM or not? We have to check it. If it is executing in SHM, what is its time period? So here plus Q is kept at midpoint, O is a midpoint. It is displaced slightly from O, midpoint, to here. So then it is displaced slightly from midpoint to here, this Q. What is the displacement here to here? X distance. Displacement is X. Okay. What is the force acting on Q? If Q is kept at midpoint, it does not experience any force, because here equal and opposite forces acting on Q due to fixed charges. Clear? Now, what force is acting on Q? So here to here distance is, we know that midpoint to Q, L. Here to here X. Remaining is L minus X. What is the distance of capital Q? Here from small q, L plus X. Clear? Now, what force acting on this? Due to this side. Ripples are positive. This is also positive. Ripple with a force F1. Here, F1 is what? 1 by 4 pi epsilon naught Q by L plus X whole square. Force acting on small q due to capital Q. So, ripple this side with a force F2. F1 and F2 acting on Q, small q, in opposite direction with different magnitude. Which is the more value, F2 or F1? We know that F2 is more. Why, sir? Less distance, same charges, QQ. This is also QQ. Less distance, more force acting on it. Therefore, if Q is displaced along the line joining them and released, what happens, sir? So here, restoring force acting on plus Q. That's why here, therefore, restoring force on charge plus Q is F is equal to F2 minus F1. Which side? Towards midpoint. So here F2 minus F1 towards midpoint. That's why here towards restoring towards here mean position or equilibrium position. That's why here minus indicates towards mean position. F2 minus F1. Sir, what is the F2? F2 is the force acting on Q due to capital Q. Therefore minus of 1 by 4 pi epsilon naught Q by L minus X whole square minus 1 by 4 pi epsilon naught right here. So F is equal to minus 1 by 4 pi epsilon naught Q by L minus X whole square minus F1. So due to this 1 by 4 pi epsilon naught Q by L plus X whole square From these two, F equal to ma, restoring force. It is the net force acting on small q. That's why ma is equal to therefore minus, which is common, 1 by 4 pi epsilon naught qq, 1 by 4 pi epsilon naught qq common, 1 by 4 pi epsilon naught qq. Okay, remaining is 1 by L minus x whole square minus 1 by L plus x whole square. Yes. Okay. Next students, m take that side. Therefore, a is equal to minus 1 by 4 pi epsilon naught qq by m into, take LCM. LCM is L minus x whole square into L plus x whole square. Remain here L plus x whole square minus L minus x whole square. So after so calculation, so a plus b whole square minus a minus b whole square, 4ab. That's why therefore here a equal to minus 1 by 4 pi epsilon naught qq by m into, this is the 4lx, 4ab means 4lx by a square, a minus b into a plus b, a square minus l square, a square, l square minus x square whole square. So here this is the acceleration of a particle towards, minus indicates towards midpoint. So as assumption is there, if it is slightly displaced, as x is very small, that means L square minus x square. Here x is very small comparable to L. And what is the meaning of this one? X is very small or small, that means x less than L. Therefore here L square minus x square is equal to L square. So here substitute instead of this one L square. Therefore A is equal to, students, A is equal to minus 1 by 4 pi epsilon naught qq by m into 4lx by L square whole square L power 4. In this, which is cancel, so 4 cancel. Okay, here L is there, L power 4, that's why L cube. So similar, after that we get minus qq by pi epsilon naught m L cube into x. X is the displacement from mean position. So this is the constant term. So A is directly proportional to minus x. A is directly proportional to minus x. This is the equation 1. So here A is directly proportional to minus x. So here what happened? A is directly proportional to minus x is nothing but the charged particle plus q executing in SHM. If it is so, it is in SHM. So it is in linear SHM. It is in linear SHM. Acceleration of that particle is minus omega square x. This is the equation 2. Comparing equation 1 and 2. Comparing equation 1 and 2. Comparing equation 1 with 2. We get so here A minus xx. Omega square value is, students, omega square value is qq by pi epsilon naught ml cube. Pi epsilon naught ml cube. So here square root on both sides, we get the relation omega is equal to root over qq by pi epsilon naught ml cube. This is the angular velocity of a charged particle if it is in SHM. So its time period t is equal to 2 pi by omega. Omega value, this substitute here, we get T is equal to 2 pi root over pi epsilon naught mLq by QQ. This is the time period of charged particle. If it is displaced slightly along the line joining them and Q is positive, it is in SHM. Suppose here Q is negative, what happened? He is executing in SHM, it is slightly displaced along the line joining them. Check it. Suppose here Q minus Q is kept at midpoint. It does not experience any force. That's why here equal opposite forces acting on it is minus Q is attracted by this one. Here minus Q attracted by this also. That's why these two cancel, net force. Now it is slightly displaced here. Minus Q is there here. It is displaced slightly. What happened? Negative charge is there. This the negative is attracted by this side, and this also attract this side. Which force is more here? Due to this one. That's why here capital Q is pull more force towards it. That's why here it does not executing in SHM if it is negative charge. Okay? Is it clear? All of you write down, students.